Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about North America charging standard. So let's dive deep into it. So before we go deep into basically the standard, we have to understand the charger side of things. Well, you have to understand the reality is EV is here to stay worldwide, meaning this is the chart from 2011 to 2021, and sales of EV has been growing exponentially. It's not going back, it's here to stay. Yes, grand total EV penetration is very low, but this is the trajectory, meaning if this is here from 2011 to 2021, you can be damn sure in next 2 or 3 decades it will start to become significant. So we need a way to charge them. Like we have EVs, that's cool, awesome, but how the heck you charge that? So we need a way to charge them too. Now there are three levels of charging right now that is active in this world. So what do you need for charging? Well, you need two things. You need power, AC or DC, and then you need handshake. Handshake is the critical aspect here. Same way like you can have a fast charger that works with only Oppo or Vivo, and it does not work with Samsung or Motorola because it's not doing the handshake. Same thing applies here. So we have multiple protocol standards and multiple AC and DC system. So AC single phase is classified as level 1 AC charging. This is the lowest thing that you can do. Now, is that useful? Well, no, not on a road trip, but it's actually really desirable for majority of people. Why? Well, assume it this way. You drive, your car has a range of 100 kilometers. Your office is, let's say, 20 kilometers. So you drive 40 kilometers every day. That's a fixed thing. You're gonna do it every day for years on end. Obviously, what's once happened when you bring the car back, you plug it in and you go to sleep. It charges slowly over time. Done. You don't have to worry about it. And same can be done. There are places where, like in office, you can just plug it in the charge. You're gonna be in office for a few hours. It can slowly charge back up. So AC level 1, just a single phase, more than good enough for majority of the scenario. Not for long trips or road trips, but more than enough for average people. That's why AC level 1 exists. And that's how majority of the cars should be charged. Then we have AC level 2 multi-phase. Now, why it's called multi-phase? Well, in India and in Canada and in Europe, we have three-phase, where you have three phases 60-degree apart. Oh, pardon me, 120-degree apart. But when you're talking about America, they have something weird where they have one phase. They still have three-phase generator. They have one phase going into a transformer, and it's a butterfly transformer. So it's like literally center tap transformer, and you get 180-degree apart. So they have two phase. So that's why it's multi-phase. AC level 2 means multi-phase, either two phase in America or three phase the rest of the world. That gives you much more oomph. So your charging speed could go from, let's say, it will take 8 or 9 hours to charge to 3 hours to charge. So that's AC level 1, AC level 2, super cheap. AC level 1 is just a plug. AC level 2, it's a three phase, but still just a cheap system. You do not need basically advanced things. All you need is a handshake device where you can do proper handshake, do proper safety, the end. Then we come to DC fast charging. Now, DC fast charging, basically this is AC, this is DC, these puppies. Now, DC fast charging is designed a bit differently. So whenever you are sending AC, your car has an onboard charger that is taking care of it. Whenever you are doing DC, DC has the freedom of size, meaning, let's say you want a charger that is capable of dumping, let's say 300 kilowatts of power. That's huge. That's freaking huge. Your car physically cannot fit the damn thing. I mean, like it can fit it, but range will go down simply because you have so much dead weight. So the idea with DC fast charging is that you have that giant unit outside and then you directly make love to the battery. All you do is communication here, make love to the battery, voila. Now, is there a benefit to this? Yes. Why? Because this is directly communicating with the battery, directly dumping battery at battery voltage. It can charge it under an hour. You can achieve like 0 to 80% in 20 minutes because these puppies are powerful. They can give you 10 kilowatt, 20 kilowatt, 30 kilowatt, 50 kilowatts, hundreds of kilowatt. Like the establishment can allow you to up to 350 kilowatts, or some designs are even almost megawatt class. So that's level 3 DC fast charging. So this is what we are talking about. So whenever you are seeing a charger that's just a very small plug, generally AC level 1, it's a bit elaborate, but not big. It's a AC level 2, 3 phase. When you're saying something huge, is generally a DC fast charger. So this is the charger part of it. So let's understand the North American charging standard. Well, this is just Tesla standard. So Tesla had this, now they are renaming it and calling it NACS. So Tesla Roadster was very early. How early? Well, it started in 2008. This puppy, basically, they bought a Lotus chassis, redesigned everything, and voila. Now, this was way too early. They had no standards, nothing. This was their original design from Mark 1 early days. So, they had nothing. So they built their whole closed ecosystem. Closed ecosystem meaning it's not control C, control V for anyone else. They had a very clever way of trolling people where they were like, you can use our patents free of charge, but we can also use your patents. It's like, what the hell? Either it's free or it's paid. This was a very weird way of like, so people who are like Elon fans, they were like, oh, Elon is giving it for free. No, it's like the reason other companies did not adopted this standard was the simple. It's like, you will use our patents. No, sir. No, thank you. So they did build a closed ecosystem. Now, what does ecosystem here means? Well, it means the physical plug that you see. It means the protocol. The handshake is complicated. That's why you cannot just directly plug stuff in. Unless you have a microcontroller that is taking care of the handshake. Yeah, at best, nothing will happen. At worst, fire. So plug, protocol, and charging network. And this part, Elon Musk really nailed down. Electric vehicle never had a problem in the vehicle part. Vehicle is cheap. Yes, I'm not joking, not exaggerating. This is cheap part. It's the same thing. People who do not understand high-speed railway think like, oh, the bullet train or Shinkansen is expensive or TGB is expensive. That's free. It's the tracks that are expensive. And same happens here. And Elon Musk really understood this. He really poured a lot of R&D, lot of research to just have this network everywhere. You buy the vehicle, this is there. And this paid off. That's the sole reason why Tesla is so goddamn successful in America. They really figured this part out. Like, you need a charging infrastructure, because be mindful, even the best lithium ion chemistry, that is lithium titaniatox system, that puppy can charge in 5 to 10 minutes. And I mean full, not 0 to 80, full 0 to 100% without damaging itself. But yeah, where would you get that much oomph? Where would you get like that, 11 kV line? That's generally what we have, 11 kV or 33 kV line, and a giant transformer stepping it down, and then giant AC to DC converters. That will be too expensive. So it's logical to have a charging standard that is very mild, but better what you can do from your home. Your home is like few hours I'm going to be here, or office few hours I'm going to be here, it's good. But road trip, you need this. And this puppy could be starting at like 100 kilowatt, then upgraded to 250 kilowatt. Now they are touching 350, and for their trucks, they are touching 1 megawatt. So this was an ecosystem. It was very successful. Car, charger. This was the smart part. This was like same way people think iPhone, Apple makes money from iPhone. No, sir. It's the App Store that prints money. So same here. Like, this was the very wise idea. However, now they have opened it, and rather than calling their own custom standard, Tesla standard, they have called it this North American charging standard. So now it's open source. Now, what does open source here mean? Simply means you can make it. You can go YOLO with it. Meaning, if you build a device that, let's say a vehicle that absorbs power from this network, it will work. Network will work with you, and Elon Musk will not file a patent lawsuit against you. You can go YOLO on it. If you design a plug that is designed to absorb energy from this, it will work. You want to do opposite. You want to charge Tesla vehicles, it will work. It's open source. It's not like, no, now we get access to your patents. No. It's just like free, open, like Linux community. So it's properly open sourced and renamed to NACS. Now let's talk about how, why. If he was truly like, I really want to help the EVs, he should have done that in early days, and that would have exponentially speeded up the process, because charging network was the weakest link. So why the heck change? And change now? Well, the politics part of it, because European Union, like this is European Union Model 3, you see that like it has CCS2. Why? Well, European Union was like very wise about this. It's like, and that's the reason why European Union does not have Tesla monopoly. They figured out very early on that thou shall have a one open standard. And this is between what Tesla did 1 year ago and like in the start. So CCS2 was very early on, built with a lot of wisdom, and they just mandated it. Like, if you want to sell cars in EU block, you have to have CCS2. And even in India we also had like random things, but now more or less, that I do not know whether it's like law, but it's like more or less every car in India, like Tata, Mahindra, all of those puppies, they are becoming CCS2, combined charge standard 2. So Europe is going ahead and USA is left behind. And be mindful, European Union is really good at, even with charging ports. They're like, they bitch slapped Apple. It's like, nah bro, give USB-C. So They did that. Now here's the Europe, USA realizing very early on that their EV penetration is not that good, because again, Tesla is good and all that, but it's expensive, and you can make an EV that is very cheap for majority of people. And the people who have dual cars, they could just simply, hey, if office commute, which is a fixed thing I'm gonna do like for 30 years of my life, I'm just gonna use a electric car. When I need to travel or need to take kids to like anywhere else, I have a fuel car. Why the heck that's not happening? Because electric car is expensive. Why is it expensive? It's only made by properly Tesla. Why is that? No charging standard. So USA decided we have to fix this stuff, and EV charging has to be standardized. They realized way too late, but they have realized. So they are going about it as American way as possible. So the idea is $7.5 billion. And that $1 billion will allow you to EV rollout network. Basically, anybody who's this is the pool money. This is not one agent is going to get that. This is a pool, 7.5 billion pool, and they're going to give money to everybody who's going to willing to build a network. So Tesla is trying to become USA default. That's why they have the name of North American. Because be mindful, Tesla knows how to make CCS2. And again, while CCS2 may not work for American household, it will work for American industry or any charging spot. Because be mindful, while AC three-phase is not in American household, it is normal for their big loads. For big loads, buildings and all that, they still have three-phase power from generator to until household. Only household gets like single phase. Everything else gets three-phase. So they could still use this, but they are like, we have already built this infrastructure. Again, genuine amount of cost has been put, genuine amount of thought and research have been put into that. They're successful with that. So instead of forced to be redoing it, they're like, hey, $7.5 billion, that's a good money. So even if you can take 50% of that, that's a good money. And it will also allow Tesla to become the default. That's good. On top of that, this will also allow them to make money from others. While other companies can like leech into Tesla, they could not do that. Well, how do I know that they could not do that? CCS1 is made in America. It was there. They never figured out how the heck you're gonna build a charger that has uptime. Uptime was their weakest link. I have linked Tech Connections, a very amazing video about that. Uptime is horrible. Most of them don't even know that you have to design a system that just accepts payment from NFC, or in case of India, UPI or things of this nature. They do not have proper apps are not tested, nothing is done, like because Tesla is completely vertically integrated, it just works. It's not the problem of the kilowatt hour or the voltage, it's just does it work or not. And 99% of the time the CCS1 that is used in America does not work. Tesla figured out how to make that puppy work. Like they tested it and they really worked their ass off into it to make it work. Now what does that mean? That simply means other companies can actually make Tesla networks, but they're not going to do that because Tesla network is not the hardware, it's the support behind it. It's the fact that you're going to go there, it's going to be working condition. So what does this mean? This means any company that is like Ford or whatever other brand, Ford or GM, they are making new vehicles. That vehicle will go into Tesla charging spot and they're going to pay Tesla to charge their car. So they're going to make money from it also. So they're making money from two sides. So first, that $7.5 billion pool, which I do expect them to take out the biggest chunk out of it because their network is the largest. Second, if they have the biggest network, most amount of users will go into that network itself. So they're going to take a lot of money from that part also. So it's a good win-win deal scenario. They could have done this earlier. But again, 7.5 billion won't be there. But at that point, he had to actually be, willing to do this. So this is the political side of it. And I'm happy that at least India has learned that CCS2 has to be there. And we are just realizing CCS2 is the king, CCS2. But America is a bit late. Let's just put it that way. Now we come to the tragedy part of it. Why Indian is talking about this charging standard. Well, India has a similar issue. While in vehicles, we have realized this is the puppy, we have really messed up the two-wheeler market. And India does have a lot of two-wheelers. Yes, I know this is an odd thing to hear from European audience and American audience, but India, we have two-wheelers, like a lot of two-wheelers, like bonkersly large amount of two-wheelers and surprisingly large amount of EVs in that pool. So that's the issue. So what should be the solution? Solution is law. Same way America is going a bit more gentle, but European Union was like, nah. CCS2 done, go home sweet dreams. There has to be a law. Now the biggest weakness I have seen in all the EVs is that EVs, two-wheelers have two categories. One is unlicensed category. If you are less than 1 horsepower, like hundreds of watt or 200 watt, 300 watt, they're not going to give license to you. You don't need it legally. But if you are like, multiple horsepower, then yeah, you do need some license. If it's in that range where it's a license, it must have onboard charger and it must use CCS2. Now CCS2 does both AC and DC. Now here's the deal. Engineers who designed this specification for worldwide use, that's the whole point. That's why it does not have any licensing lock. It's like open source. Is that they realized very early on, for some designs you may need a smaller plug. You do not like this huge ass plug. So DC has 3 levels here. So you have AC single phase, AC triple phase. Done. Yeah, you can do 2 phase also, but AC 1 phase, 2 phase, 3 phase option, good, go. But what if you need to fast charge while using the same plug, smaller plug, you want to fast charge using that? So let's say these Ola scooties, they could literally use DC mid and low specifications, meaning DC low, DC mid. So what is this DC low and DC mid? Somebody realized very early on is that not everything needs bonkers amount of amp. For example, this thing was designed to be bonkers. So it supports 500 volt. This is older specification. Now it has been ramped up. But be mindful, for 99% of the car, this like, unless you are talking about Hummer or some extra weird cars, 400 volts is more than good enough. Some companies are going to 800 volt, but odd. So 500 volt, and yes, it has been revised to higher voltage, and it supports 200 amps. That's a lot of kilowatt. That's more than enough kilowatt to do everything that you need to do. So what about these vehicles? They have very small batteries. Sometimes they literally have 48 volt battery banks. So how the heck are you going to charge this? Well, you have an AC onboard charger that would be low power. It will have 2 modes of operation. Line 1 option, meaning if there is only 1 phase fire in your household, go ahead, slow charging, but it will charge. Then you have 3 phase. It will be faster, but it won't be super fast. It will just like, okay, it's a bit faster. That's good, awesome. For majority of places, that 3 phase power AC delivery is kind of cheap. It can be done quite effectively, let's say in garages, parking lots, things of that nature. So that's why you do want 1 phase and 3 phase support. Then we have DC. It will just remove the L3 and L2 from AC line and connect it to DC plus and DC minus. Benefit of this is, like, while you have 2 plugs and this is not as big as this, so your amp rating goes down. So from 200 amps DC, you drop to almost 70 amps. Now here's the deal. 70 amps for these puppies, more than good enough. Even with lower voltage, be mindful, the tank capacity, as in like kilowatt hour, they are generally in single digit. Like they do not have like 50 kilowatt hour tanks. The tanks on these puppies are very small. So that amp rating, it may sound small, it's more than good enough for these puppies. So not only they can receive AC charging, AC multi-phase charging, AC level 1, level 2, DC fast charging on the same plug. It won't be the big gigantic plug, it will be the same plug. They can just use the same plug, DC low specification. But let's say two-wheelers, some companies are also working on making basically DC fast charger for super bikes. That will require a bit more oomph, and specifically if you are using some better chemistry, so like lithium titanate. Range capacity would be less, but it can absorb way too much oomph. The C rating is bonkers, like C4 is possible. C1 means 60 minutes, C2 means 30 minutes, C3 means 15 minutes, and you can say halves every time. So C4 is bonkersly fast. So at that point your amps will go up. But here's the deal, engineers knew this. What if instead of using only 2, we use 4 links? You still have your communication that is completely isolated. So low voltage communication, completely isolated. The center protective earth, completely isolated. So everything safety critical, you do not touch, and you just parallelize the rails. Now you have 140 amps and same voltage rating, 500 volt. We designed this. Like, this has to be India's answer to it, because this also solves another headache. If you have AC level 1, level 3, level 1, level 2, anything can use anything else. For example, your scooties, same plug. Your cars, same plug. And if you have DC fast charging, yeah, then there will be a minor issue. But again, at least you won't be stranded. You will be like, yeah, either I'm charging slowly or you're charging fast, but I won't be like, it does not plug in. Because these things are proprietary. So this is what Indian government has to do. Like CCS2, because CCS2 is already standardized for cars, but this DC low and DC mid. So for people who are like, we need small plug, which I'm like, dude, this is, while it is big, it's not that big on your end. Yes, you need 2 extra cables, but your cable shielding, cable amps is directly proportional to your battery. Your battery is not huge. It can be done. Of course, they have to redesign it. They have to spend some time on it, but it can be done. It's not like, oh, it can't be done. Tesla does it. So it can be done. Or if they really want like small, sleek system, again, you have DC low and DC mid to take care of you. This will allow cars and two-wheelers to use the same ecosystem, which is a important thing in India. And on top of that, it also allows backwards compatibility, meaning if you have DC high only, again, DC high users can still use your plug, but they will be running on AC mode. So they won't be stranded if like, hey, oh, my battery ran out just I'm 1 kilometer away. Okay, you plug it into this AC1 system. Slowly charge it like 15-20 minutes. It will only give you a few kilometers. Then you just go to there, charge it full speed. So backwards compatibility is desirable. Same way like your USB 3 does work with USB 2 ports. Same thing here. So we have amazing solution, and everybody's like, but like, what if we create our own ports? And there is this one company which made really good Altair scooty, really good scooty. And then they were like, whew, and they were like, we're going to take CCS2. Instead of having this 2 connectors like that is standard, they literally took the same mold and put 4 connectors there. No reason. They just had to mess that part up. At least Ola, I could say it was a Netherlands company, but they really redesigned everything. It does not have any AC absorption. So its charger is literally AC to DC on board, and then you dump it into the body. So this is a genuine tragedy in India because these things are increasing in number, and if we do not standardize it now, we will be stuck exactly how America got stuck. So this is something that we have to sort. And like again, a solution is there. DC low is there, DC mid is there. Solution is there. It can be done. Today, it can be done. So what can we expect in the future? Well, in the future part, you have to understand, hopefully will not all this hassle, the DC charging. AC will have like 3 levels. AC 1, single phase, AC 2, which will be AC level 2, which will be like 3 phase, and AC 3, which will be like high amp AC. Now, why would you want that? Well, the reality is DC is expensive, like super duper hyper expensive. Like, and the why Tesla is so smart at like actually delivering the network, they realize they are using the car part here. So every car, electric vehicle has a AC on-board charger, and that's why your charging speed is limited on AC. So this is a very high power unit. This is a 20 kilowatt unit. Most cars will only give you 10 kilowatt unit. So if you plug in 3-phase AC power, it goes here and DC high voltage comes out of there. And of course, it does require cooling. So again, your vehicle has a cooling structure. It will just plug into that manifold. So everything is fine. Everything is dandy. But here's the deal. How the heck the giant 200, 300 or 500 kilowatt unit works? They don't. So somebody figured out, like this is what Tesla figured it out. They have the same thing, same manufacturer that manufactures this puppy for them. They just took it, stacked multiple of them. That was clever. That was like, I have to give it to them. That was clever. Rather than re-engineering it, they're like, hey, take this. Like instead of ordering 1,000 pieces, they're like, hey, order 10,000 pieces of that. Because be mindful, a car will only take 1 piece. Chargers will take hundreds of that. And it also gives them redundancy, meaning if in case, let's say one goes poof, so 20 kilowatt will be taken off. You will not lose the entire 350 kilowatt. You will be like, okay, 1 unit poof, but no problem. And because you are buying bulk order, you're also getting a benefit in terms of maintenance and reliability and all that jazz. Other companies also use the similar principle. They have blocks, but those blocks are not car blocks, so they are a bit bigger but a bit more oomfish. So this each unit could be 20 kilowatt. Again, companies will give you what exact specification is. Other could be as high as like 1 unit could be 50 kilowatt. They are expensive. They are bonkersly expensive. So what is the weak link in this whole ecosystem? Well, is the onboard charger. Imagine if this puppy could directly absorb as much as you need to. Let's say if your car battery can only absorb 250 kilowatt and it dumps 250 kilowatt, all you would need is AC connector. AC connector would simply be a contactor, a microcontroller that does the safety, some voltage coil, current reading coils, and some voltage sensors. Done. Go home. Super cheap, even at 250 kilowatt. These things cost millions of dollars. Not joking or exaggerating. They actually cost that much money. And I'm just talking the AC to DC part. You not only need a basically high voltage connection directly to that charging spot. It could be 11 kV or 33 kV. Then going to a giant transformer. That transformer feeds into these things. And they consume money like there is no tomorrow. And they need a lot of maintenance. So what if we eat this part of it? You still have the transformer, but again, transformers are cheap. This is the expensive part. Transformer is still there. You just have a contactor. Just electrical contactor. We know how to build those. And AC is very easy to disconnect. AC contactors are 1/10 the price of DC contactor, same kilowatt rating. So how can we do that? How can we remove this weak link? Well, right now nobody has figured it out, but I can guarantee you the company that figures it out would be rich. Same way Tesla figured it out. It was the charging the weak link, not anything else. So Motor driver is the only thing in a car body that has the oomph needed to actually charge a battery at like full capacity. Actually, it has more oomph than, because again, your battery will take, let's say, 20 minutes to go from 0 to 80. Your car can discharge faster than that if you're going like all out. What is dumping that energy is the motor driver. Now, can motor driver take AC and charge a battery out of it? Yes, that's exactly what regen is. That's exactly what's happening. Majority of the car have three-phase AC motors. Again, it could be magnet-assisted synchronous motor, it could be normal induction motor, whatever have you. Generally, they have AC three-phase motors. So that means it can absorb three-phase, and it has, most of the systems have what we call regenerative. That means it has the technology to take three-phase AC, dump it into battery. So why don't we use that? Well, it will require a little bit of engineering. Now, what is the biggest weak link in this topology is the frequency. So these things are designed to run on very low frequencies, like these puppies. They are in America, so they are a bit lucky. They have to only work at 60 hertz. In India, they have to design to be work at like 50 hertz. What about the motor driver? Yeah, 500 hertz. So that's the primary reason why it's so small. But again, they do design it such a way that it can work at, like, again, varying RPMs. So it does have the ability to do that. And there are some topology that allows you to deal with this sort of issue. Can it be done? Indian Railway locomotive has this technology where it just takes giant energy from transformer, drives the motor driver. When it's doing regenerative braking rather than doing resistor heating, it dumps that energy back into the cable. We have this for past 10 years. So it's only a matter of time until a company figures it out. Basically, yeet this puppy, instead of basically between motor driver and the motor, put a giant three-phase contactor that allows you to disconnect the motor, connect the charger, plug AC level 3, and like level 3 simply means high amp in AC, 100 amps or 200 amps per phase. You plug it, you're good. And that way, charging station will become super cheap, easy to make, easy to maintain, and everybody will have it. At that point, we'll like really solve electric charging issue. So until a company figures out how to yeet this puppy, have that sort of topology engineering, be mindful. It can be done. We know that, like, again, otherwise regen would not work. It's just that making sure how do you make love with like a different frequency. Be mindful, back in the days it was not possible. Look at your old days of 100 watt. If you have talked about any power adapter that takes AC into low volt DC and it's 100 watts, people are like, whoa, it was this big. Now you can put that in your pocket. We have that, so it can be done. Gallium nitride technology, better silicon technology, silicon as in like the controlling mechanism, both advancements allows us to really do some weird things that impossible long ago. Now it's possible. So I'm just waiting until some company figures out that this is unnecessary. This is unnecessary. Motor driver, of course, they may need to beef it up, which I do expect it. They may need to beef up the cooling also. I do expect that. But again, problem solved. AC three-phase is super cheap. That's why we use it. So that's the future. That's what future I am hoping for. So this was my presentation on North American charging standards. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.